Hi, everyone. How are you all doing today? Hope everyone's having a good day so far, wherever you are in this wide, wide world of ours. Um, my name is Darcy Lemons, and I am one of APQC's knowledge management subject matter experts. I am so delighted to be here with you all today, and I'm just excited to be a part of today's conversation. This is APQC's February Knowledge Management webinar. Last month, some of you may have joined us, and Cindy Hubert and I talked about some of the lessons that we've learned from the front lines of helping organizations design and implement their content management processes and systems. This month, we're shifting topics just a little bit. We are going to focus on what I consider to be a perennial favorite, which is culture. We here at APQC have done a lot of research in this area, and we have lots of resources available to you all in our online resource library, like our collection of resources on promoting KM and making it stick. However, there's nothing like hearing a really good real life story. So I'm excited that we have one to share with you all today. APQC and NASA have enjoyed a relationship that has spanned more than 2 decades now. I was kind of amazed when I really thought about that this morning. I was thinking back to the first time I had any interaction with, I believe it was with Jean Holm at NASA's Jet Propulsion Laboratory. And what a wonderful woman, what a wonderful conversation. But oh my gosh, more than 2 decades ago, y'all. NASA has been an active participant in APQC's knowledge management research on best practices over the years. They have graciously talked at our conferences and other webinars, participated in our KM advanced working groups. We've just really enjoyed the relationship over the years. So I'm excited that today I have the privilege of introducing Roger Forsgren. Roger was NASA's Chief Knowledge Officer from 2015 to 2021 when he retired from the organization. And he's going to share with us the story of how knowledge management helped change the culture at NASA. And I want to say that I believe that what Roger is going to talk about is a missed opportunity in many organizations. That's all I'm going to say about that, because I don't want to give away any spoilers, but I want to see if you can figure out specifically what I'm referring to. So I'll be watching in the webinar chat and in the questions section to see if anybody figures out what I just referred to. So Roger, thank you so much for joining us today. I'm going to hand things over to you to introduce yourself and start your story.
All right, thanks so much, Darcy. It's an honor to participate in this and work with the APQC, and I really appreciate your support and your help. Before I get started, I want to notice the title is how knowledge management helped change NASA's culture. I want to make sure everybody understands that knowledge management did not change NASA's culture. Changing a culture in an organization, especially one as big as NASA, is a monumental task. And it's something that management has to be behind and management has to be determined to do. But knowledge management is a fantastic tool that can be used to help any organization change their culture. A little bit about me. My first degree was in history. I majored in history, got a bachelor's degree. Once I graduated, I had a hard time finding a decent job or a real good career. So I decided to start things all over. I started as an apprentice mechanic up at NASA's Research Center in Cleveland, Ohio. While I was there, I went to 10 years of night school to earn both an undergraduate degree in engineering and a master's degree. Most of my time at the Glenn Research Center in Cleveland, I worked as a technician and later as an engineer on the shuttle program, developing and designing and building microgravity experiments that flew on the shuttle. In 2005, I became involved with training and I was transferred to NASA headquarters. In 2015, I was selected by NASA to be their Chief Knowledge Officer, and I retired in 2021. Since retiring, I wrote 2 books. The first one we're going to talk, is mostly this presentation is based on, is Lean Knowledge Management: How NASA Implemented a Practical KM Program. And my second book was just published a couple of weeks ago. And its title is When Graduation's Over, Learning Begins, Lessons for STEM Students and Professionals.
Ah, yes, our first poll. So Roger just introduced himself. We'd like to learn a little bit more about the people who are on with us today. So Talene, if you'll start the poll, we'd like to learn a little bit about how widespread knowledge management is in your organization. So please select the response. We'll give you all a few seconds to chime in, and then we'll share the results. Roger, while they're entering their responses to that question, I just want to say you haven't rested on your laurels since your retirement, having already, I mean, that's, 2 years, give or take a month or so here and there. And, you've already got 2 books, and that's quite impressive. You've kept busy.
Yeah, well, you'll find out someday, Darcy, when you retire, you have to keep busy. You have to keep your mind occupied. And otherwise, the days and everything just flies by so quickly.
It does. It starts to blur together. That's other people that have shared the same with me. Thank you, Talene. All right. So we've got a nice mix of participants here in terms of the how widespread knowledge management is in their organization. The biggest percent by far that KM has been formally implemented in a few areas, followed by a significant group, about a quarter of y'all, who are in the process of developing some strategy, and then almost equal in size, some KM activities, but nothing formal, and then a few that do have enterprise-wide KM programs. It's a quite extensive KM programs. Thank you all for sharing with us. And we're going to continue the story now. So Talene, if you'll put us back in slideshow mode, there is another poll coming up, so you'll have an opportunity to share with us once again, but we're gonna let Roger get back to his story.
All right, I told you a little bit about myself. Let me tell you a little bit about NASA. This is one of my favorite topics to talk about. NASA has approximately 18,000 civil servants. The average age is 46. So if you're involved with knowledge management, you realize 46 is an aging workforce. And this is where knowledge management is critical, because you have an aging workforce and people that have some tacit knowledge that needs to be transferred someday and somehow to the younger, new people that are coming into your organization. To put this into context, during the heyday of Apollo, the average age at NASA was 28 years old. And if you look today at the average age at SpaceX, it's 29 years old. So NASA also has approximately 60,000 contractors across the country. And our fiscal year 23 budget was $25.4 billion. Now, this is about less than 0.5% of the United States federal budget. In comparison, if you look during 1966 in the heyday of Apollo and the effort to go back to the moon, NASA's budget was a whopping 4.4% of the American budget. What's NASA doing with all that money? Well, I want to talk a little bit about NASA today and some of the major programs that they've had and some of the major, absolutely spectacular successes they've had. The first one is the ISS, and this is, this is a spectacular engineering achievement because that's probably why so few people know about it. There hasn't been any, major issues or problems with it. It's been working, for over 20 years now in low Earth orbit. It costs over $100 billion, which makes it the most expensive project ever, single project ever made. It's also was the most difficult project to construct because it was built. The modules were assembled by astronauts in low Earth orbit. It's really a stunning achievement. It's the size of an American football field, and it travels at 17,500 miles per hour, and it orbits the Earth every 90 minutes. And you can buy apps, and you can actually see the space station travel overhead. There's apps that'll tell you where it's at and what time you can see it at night. And it really is a spectacular sight. It's a really bright white dot that just travels right across the sky. I really recommend, and every time it's available in the Florida area, I definitely go out there on the beach and take a look at it. JWST, this was launched last year on an Ariane 5 rocket. The total project was estimated at about $10 billion. It's now parked at Lagrange Point 2, which is 1 million miles from Earth. If something goes wrong with it, there's no way the astronauts can get there to fix it. There's a lot of risk in something like this, especially something so expensive and complex, but there's also an awful lot of potential scientific knowledge they're going to gain from it. SLS, a space launch system. This was first launched in November of 2022. It was an unmanned rendezvous with the moon. The mission performed flawlessly. This is going to be followed in 2024 by a manned mission to the moon, and it's also another test flight for the SLS. But in 2025, SLS is going to send astronauts back to the moon, where they're going to make a permanent base on the moon. Commercial crew. This originated about a decade ago, and it's a partnership between NASA and SpaceX, as well as NASA and Boeing. The United States government has decided to turn over low Earth orbit to commercial companies like Boeing and SpaceX, and NASA is going to concentrate more on exploring the solar system. NASA has done extensive planetary research on Mars. Currently, there's three rovers, operating rovers on Mars right now, 2 American and 1 Chinese. And then NASA is also very much involved in aeronautics. They're working on supersonic aircraft, and the hope is to get better fuel and noise capability, so these supersonic aircraft can fly over land. You don't have to worry about sonic booms breaking everybody's windows. These are just some of the major programs at NASA. NASA has a very large portfolio of scientific and engineering projects, and I highly recommend anybody who's interested to go onto nasa.gov and take a look at what we're doing. NASA's also had a difficult history, and a lot of these successes we've had are born because of failures in the past and failures that we learned from. The Apollo 1 in 1967 almost completely derailed our efforts to go back to the moon. 3 astronauts perished in a fire within the capsule during a test run at the Kennedy Space Center. The Hubble Space Telescope was launched in 1990. Once it was in orbit, they discovered that there was a manufacturing error with the mirror. Fortunately, it was very embarrassing for the agency. This was an extremely expensive program. But fortunately, it was in low Earth orbit, and astronauts were able to get there with the shuttle and to repair it. And it's been operating just perfectly ever since. NASA in the past, in the late 90s, has tried to start research and going back to Mars, but they had 2 spectacular and very embarrassing failures. The Mars Climate Orbiter in 1998, there was a mistake where there was actually a communication mistake, which most mistakes tend to be, but the contractors had programmed the probe in metric units, and the flight controllers were dealing with English units. And unfortunately, the Mars Climate Orbiter, rather than landing on the planet, kind of slingshot off it into space and was completely lost. The Mars Polar Lander, there was also another technical error with that, and it crash landed into the Mars surface. And then the 2 that I'm going to talk about today that really are, I think, are the major reasons why NASA was able to change its culture: the Challenger accident in 1986, and then the Columbia accident in 2003. If you were around in 1986, I'm sure you remember where you were when the Challenger blew up after launch. I was an apprentice mechanic up in Cleveland at the Glenn Research Center. I was in a tool room. Somebody came by and told me that the space shuttle just blew up, and I didn't really believe it, because space flight at that time had become so routine, and it just seemed like NASA, couldn't have an accident of this proportion. What happened because of the Challenger tragedy, NASA management had decided to launch despite objections from NASA engineers. January 28th, this was the coldest temperature ever recorded in Florida at the Cape. It was 18 degrees Fahrenheit. NASA's own procedures called that the shuttle couldn't be launched until it was at least 40 degrees Fahrenheit. One of the engineers that was trying to convince NASA management that to wait at least until the temperatures warm up in the afternoon, or wait until the following day. That engineer was told to take off his engineering hat and put on his management hat. And as we all know, and we found out later, the technical reason for the failure was the brittle O-rings on the solid rocket motor failed, and that caused a catastrophic failure. President Reagan at the time authorized a commission to study this. It was the Rogers Commission, and their report said that, yeah, of course, that it was the O-rings that technically caused the accident, but this is an accident rooted in history. It was a decision-making process that led to the launch of Challenger. Bob Eberling was a young engineer, a brilliant engineer at the time, somewhat mild-mannered, but his role during the decision-making process was he's trying to convince NASA management not to launch. And he failed at doing that. And it's something that stuck with him his entire life. And it was something that actually haunted him the rest of his life. He made a comment that I think that was one of the mistakes God made. He shouldn't have picked me for that job. Next time I talk to him, I'm going to ask him, why me? You picked a loser. And Bob Eberling actually just passed away about 1.5 years ago. How did NASA deal with the aftermath of the Challenger? Well, this isn't the way that you share knowledge and learn from your mistakes. They recovered the debris from the bottom of the Atlantic Ocean, and then it was actually buried into a abandoned missile silo on the Cape Canaveral side of NASA's Kennedy Space Center, and it was covered with a gigantic concrete block, almost like a tomb. 17 years later, the Columbia tragedy, a piece of foam came off of the main fuel tank, hitting the leading edge of the orbiter, causing a hole. And then upon re-entry, in that hole, a plasma formed when it hit the atmosphere of the Earth, and then the vehicle broke apart over the Texas prairies. Again, this time President Bush formed a commission, the Columbia Accident Investigation Board. They developed the CABE report, and what they said was NASA's culture had never changed. For years, NASA managers were aware of previous foam strikes and warnings from their engineers, and they refused to do anything about it. This time action was taken, managers were fired, some were reassigned, and President Bush ended up ending the shuttle program. But I think one of the most critical things that happened after the Columbia accident, one of the critical ways that NASA's culture began to change was the implementation of technical authority and dissenting opinion. What this means is that on every project team, every member has not only the opportunity to speak up, but has a personal responsibility to speak up if he or she sees something wrong, especially if it has to do with health and safety. And every manager has a responsibility to listen. If they can't come to an agreement, if necessary, independent subject matter experts will come into the program and project, and they will make the decision. And these are independent, they're objective, they're not paid by the program or the project. So they come in there and they assess the situation, and they're the ones that would make the technical decision. This is a critical difference from the way NASA had been run in the past, and program and projects at NASA had been run in the past. Then also in 2011, the Aerospace Safety Advisory Panel, the ASAP panel, and this is a group of distinguished people from the aeronautics and space industry. They're appointed by Congress, so and they report back to Congress. So obviously NASA management listens to them. And they, in 2011, they insisted that NASA appoint a chief knowledge officer to enable the agency to learn from the past. They also said that NASA is good at gathering knowledge, but not good at disseminating it to its employees. And the ASAP tasked NASA with finding a way to share the kind of critical knowledge that they have with their employees. And they put some meat behind this too, because the knowledge management was given organizational respect. It was located in the office of the chief engineer, and the chief engineer of NASA, who's obviously, when you have 18,000, almost 18,000 engineers, and this is the leader of the office of the chief engineer. It brings a little, backbone to knowledge management and chief knowledge officer. So what do? We decided to what we developed something called lean knowledge management. You can only define critical knowledge in an organization when you discover and you define who your audience is. And for us, we decided it was the NASA technical workforce. NASA is a big organization. There's procurement people, there's financial people, there's legislative people. But what we wanted to do was concentrate on the technical workforce. These are the men and women on the boots on the ground, the people that have to get the job done. And it became that our only purpose was to make sure that we can make their job easier. The second thing we wanted to do was to keep it simple. We wanted to avoid academic jargon. People, the NASA technical workforce isn't really interested in taxonomy and the other academic portions of knowledge management, which are of course critical and important for developing a good knowledge management program. But our folks just we wanted a system where we could help make their jobs easier. Another thing we did was develop a one-stop website. It's apple.nasa.gov. And I recommend, the reason we did this was because in the past, there were dozens of websites for lessons learned from different programs and projects and different different NASA centers. What we want to do is combine everything so that somebody on a program or project who was searching for information or searching for case studies or even for a course that they wanted to attend knew that they only had to go to one website rather than kind of fish around throughout the agency's countless servers to try to find that information. And then the other thing that I think was critical is we decided to combine knowledge management with agency training. Because I think, when you look at it, training is the perfect conduit for transferring knowledge. And it is a seamless combination. The other thing we had to do is define for our audience what was explicit and what was tacit knowledge. And explicit is the easy stuff. And my friend, Dr. Clifford Motto, defines it as knowledge that is transferable through media, such as procedures, databases, rules, and regulations. And for us, that was basically like lessons learned databases, the easy stuff. It's out there. It's easily transferred between people. The tough one is tacit knowledge, and this is expertise and knowledge within an organization, primarily located within the brains of employees, and it cannot easily be transferred. So again, how are we going to effectively disseminate this tacit knowledge? How are we going to get it? How are we going to transfer it from the older folks at NASA to the younger people coming in? And the way we did that was to combine knowledge management with agency training. What we wanted to do, and we strived to do, and I think we accomplished, was to develop knowledge events that resonate with our audience, develop coursework, forums, podcasts, anything that we were trying to transfer knowledge with so that people would be interested and want to attend it. We developed coursework that emphasized learning from the past, that held case studies, relevant case studies like Hubble, like Challenger and Columbia. We also wanted to develop critical thinking skills. And this is, usually there's more to a problem than just, the simple solution that sometimes you see. Sometimes engineers see that. They see low resistance, they think they need to change a resistor, or low airflow, change a filter. But sometimes there's things hidden behind there that you need to research. And these are what critical thinking skills really help an engineer understand. And then cognitive bias and decision making. This is also a problem where, particularly at NASA, where an engineer may have been working on a design for months, and he or she comes into a meeting and has to, wants to defend that design. And because they have so much, they put so much effort, and time, and thought into it, they go into the meeting with their mind already made up that they're not going to make any changes, for example, or that they, aren't able to kind of listen to advice that's coming from other people. So there's a whole bunch of different cognitive biases that we concentrated on. But what we want to do is make sure our employees were aware of cognitive biases, particularly when they're interacting with other engineers and scientists on project teams. And then we also wanted to do video interviews with leadership and practitioners. This is the real beauty, I think, of knowledge management. It can be a two-way street. You can use knowledge management to interview leaders and find out, what we used to call their best mistake was, and learn from their failures and how they grew from a failure. But knowledge management can also be utilized by an organization's management and leadership to share what their strategy and what their vision is for an agency. Another thing we developed are podcasts, and I think this was a brilliant idea. And podcasts are a real popular venue for sharing knowledge with younger folks. And what we try to do is develop one 15, 20-minute podcast, perhaps every 2 weeks. We'll interview, as I mentioned earlier, we have a lot of elderly, we have an older workforce. Some of them are getting ready to retire. So what you want to do is go out and talk to them and find out from them some of the lessons that they've learned throughout their career. And podcasts are an excellent way to spread that information, because you're generally having a younger audience as listeners. So it's a great way of sharing tacit knowledge. And then leadership and mentorship programs I think are critical to not any knowledge management effort. Well, mentorship, just the idea of mentorship is placing younger, high potential employees with upper management leaders, so that the younger people can understand how decisions are made on the 9th floor and how decisions are made within the agency. I think as far as changing the culture, what we really wanted to do was to make the NASA employees never forget Apollo 1, Challenger, and Columbia. NASA, as an organization, implemented January a day of remembrance, where every NASA employee is, especially if they're on a program or a project team, they get together and they talk about Apollo 1, Challenger, and Columbia. And they talk about their own experiences on their own projects to make sure that these type of accidents never happen again. And what was different also that NASA did after Columbia, as I mentioned earlier with Challenger, was buried in a tomb with debris is never to be seen again. NASA did something radically different. They developed the Columbia Room, and the VAB was one of the huge buildings at the Kennedy Space Center. One room was set aside for all the debris that was brought in there, and it's like a museum piece. I've been through there 3 or 4 times, and it really is an emotional experience. You kind of feel like you attended a wake or a funeral, because you can see the landing gear with the still dripping red hydraulic fluid years and years later. You can also see the windows that the astronauts were looking out of when they re-entered the atmosphere. And you can also see some of the personal effects that the astronauts that were discovered out in the prairies in Texas that belonged to some of the astronauts. One in particular I remember was a little teddy bear doll that some child must have given one of the astronauts to carry on board with them. And this was found and brought back. And it really brings in the human and the emotional side of the tragedy. What we want to do is make sure NASA employees that have an opportunity to visit Kennedy Space Center go to the Columbia Room, and it gives them an idea that their job is important. The decisions they make back at their centers on hardware can have a ripple effect, and it can affect the lives of astronauts, and can affect the lives and health and safety of anybody dealing with their designs. What we did for trying to share knowledge, not everybody can get to the Kennedy Space Center. So what we did was we developed a Columbia agency tour. What we want to do is make a more positive theme. What can be learned from the Columbia tragedy? And there's 10 NASA centers. We go to each NASA center. We bring some of the artifacts, Columbia artifacts, with us, keep them on display. We bring people in there like former flight controllers that were there waiting for the Columbia to come in, and talk to them in a forum type of atmosphere, and see what it felt like to know that the responsibility that they had for the safety of the crew, how just kind of the decision-making process went wrong, and how we can learn from it. And also, of course, we talk about technical authority and dissenting opinion. We want to make sure that that is stressed always throughout the agency. Also, how we helped change NASA's culture We wanted to nurture an environment of transparency and openness. Talk about my best failure. A willingness to talk about failures. Failures, rather than something that needs to be punished all the time. Failures can be an opportunity to learn and grow. And again, I think one of the backbone of changing NASA's culture was the implementation and of the technical authority and dissenting opinion. You've probably heard of Gene Kranz. He's one of the famous flight controllers from the Apollo era. And if you saw the movie Apollo 13, where he shouted to his team that failure is not an option, that these astronauts are not going to die on his watch. And then he also said, there is no achievement without risk. And you try to balance that failure and risk, and it's not an easy dichotomy to solve for any organization. But I think it's for knowledge management, I think it's a real opportunity. Through failure, NASA became a better and a more effective organization. You always want to avoid failing, but you don't want to be afraid of failing. It can be an unfortunate part of the process, but it's not really failing if you learn from it and you grow from it. And this is not only a case of an organization, but also for an individual. You're going to fail, but if you learn from your failure and you grow from it and become a better person and a better organization, I mean, isn't that what knowledge management is all about? And I'd be more than happy to answer any questions people may have. And if you want to follow up and talk about anything, my email address is rforsgren4@gmail.com. I'd be more than happy to continue the conversation.
Thank you, Roger. We do have some questions coming in. Before I get to those, though, I wanted to ask Talene, did we have a second poll question? I wasn't sure, so I was going to see if we could put that up there real quick. If we don't, then I'll move right on into the, move right on. There we go. So we did want to ask you all, what perspective does your organization, how does your organization view learning? Is it viewed as failure? Is it viewed as a learning opportunity? So if you would select your response, and we'll give you a few seconds to enter that response, and we'll share those results back out. Roger, because I mentioned to you early, before our webinar started, that I do see sometimes that we're missing an opportunity to learn from those failures. That sometimes we do couch them and capture them as in the form of lessons learned, but also sometimes those don't go far enough in terms of really understanding what happened, why it happened, and what do we need to do different or differently in the future. Is there a process change? Is there something we need to change to this product specs? Is there, what do we need to do differently in the future to avoid repeating that failure?
No, absolutely.
So, oh, good. Look, 2/3 of the people on with us, some say yes, sometimes depending on the area of the organization and the leaders, that they do look at failures as a learning opportunity. That's wonderful. And then another group there, yes, they do. Oh, that's awesome. I'm so glad to hear that. Okay. Having said that, I think that couches some of the questions that I'm going to share with you now. Thank you all for wow, they're really coming in now. So I want to start with one that several of y'all have posted in the question and answer session. So the first one is really Roger, how did you all determine what knowledge or what topics to focus on when you were looking at you were talking about identifying the critical knowledge earlier? How did you all categorize that? How did you land on which topics to really focus on? And were engineers or others involved in those discussions to determine those topics?
Yeah, I think the critical way that we were able to determine the kind of knowledge that needed to be shared at NASA was to look at our audience and define our audience. Mm-hmm. And there's IT people at NASA, a huge group of people. There's procurement people, there's finance people, there's people that deal with Congress. But what we wanted to do is focus on the technical workforce. And once we did that, it helped us define what kind of knowledge we were going to go after. And it's
Mm-hmm.
certainly the IT folks and the procurement people and all the other people have critical knowledge that they need to share amongst themselves. But it's the technical workforce doesn't really need to be involved in the lessons learned from procurement or the lessons learned from legislative affairs and things like that. They're worried about the best way to build and design hardware. So I hate to say that we eliminated the IT people or wouldn't allow them into our program, but we're in the office of the chief engineer, and
Mm-hmm.
the chief engineer deals with the programs and projects. So we had a focus on the technical workforce. And certainly if the IT folks wanted to develop their own knowledge management program, or the procurement folks, we would be more than willing to help them. But sometimes it just gets overwhelming with the amount of information out there. So you got to filter through it. And the only way we were able to do that was to define our audience and stick to that technical workforce.
Okay. Yeah, it is, especially like an organization like NASA, well, any organization really, because if you think of, our organizations, we all have HR functions, human resource functions, we've got finance and accounting functions, et cetera, right? And so determining the knowledge that's important and having a way to segment that or filter for it once you've, through whatever repositories that we're using, or the different mechanisms like podcasts and things, and tagging for different categories. So it's easy for me as a XYZ person in my XYZ role in my organization to find the XYZ knowledge that's important to me.
Exactly.
Yeah. Staying with that for a similar theme for just a moment. Do you mentioned earlier that there's you've leveraged training heavily, building the knowledge, integrating it in with the training. You mentioned the video interviews. You mentioned and you mentioned podcasts. Do you all also? Someone is asking. Do you all also leverage communities of practice to help facilitate some of that tacit to tacit knowledge transfer, if you will?
Yeah, there are communities of practice within NASA, and it's something that when I was a chief knowledge officer, I wasn't too much involved with. But after I retired, Tiffany Smith took over, and she's doing just a fabulous job as the chief knowledge officer at NASA, continuing on the tradition, and I think and building and growing the tradition. And I think she's definitely been more involved with doing those communities of practice roles.
Okay, great. Okay. And then someone else was asking, they're very interested in the podcast. So a couple of other people have asked, how did you all identify, I guess, podcasts as a mechanism for not only for capturing, but also facilitating that transfer of knowledge?
That's interesting that's a great question. When my deputy at the time, Steve Angelillo, came up with the idea, I thought, well, I wasn't even aware that podcasts were out there anymore. I thought it was something, I heard about them 10 or 15 years ago when the internet first started. I never paid much attention to them, but he kind of woke me up to the idea. And the young people, and I have children, I asked them if they ever listen to podcasts, and they said all the time, on their commute to work or when they go running or anything like that. It's just a great way for them to learn while they're driving in a car or whatever, or just have nothing else to do. And the podcasts that we did just worked out fabulously. And as I mentioned during the presentation, it's what a great venue or conduit between when you interview an experienced project manager or in a podcast, that person can share that tacit knowledge with a younger audience that's geared up for podcasts.
Right. That's a great point there. Somebody else was asking as well, bridging the generations in NASA, because like so many organizations, you all have multiple generations represented in your workforce.
Right.
And so the podcasts themselves kind of lend themselves to that. Did y'all find that there are other some of the other approaches that you're using also lent themselves to bridging those generation gaps?
Absolutely. I think mentoring is one of them. And
Mhm.
the real beauty about developing, we have a leadership program at NASA where we take high potential engineers and for 18 months, we send them off to another center where they're assigned a mentor on a project team, somebody that they can learn from, somebody the lessons that this person learned throughout their career can be, transferred in a way, in a personal way as a mentor to this trainee. And the other
Mhm.
beautiful thing about mentorship is that it works both ways. Uh, Certainly, a young person can learn from an older, more experienced person, but an older, more experienced manager can learn from a young person. What motivates
Mhm.
a younger generation? What interests a younger generation? So
Mhm.
it really is a beautiful way of sharing knowledge, and it's a two-way street. Your older, more experienced person is learning, and so is the younger, newer person.
Right, absolutely, absolutely, and that I think that's like you just said, that's part of the beauty of it is that it does help facilitate that two-way sharing there. And staying with the mentoring for just a moment, someone asked if there was any online resources that you all have that maybe describe your mentoring program in more detail that they could have that
Sure,
they could access.
sure. I meant to mention that. Apple.nasa.gov, APPEL.nasa.gov is the website. As I mentioned earlier, it's a one-stop shop website that we developed, and it's kept up to date. It's very well organized, and it's called the SELP programs, the Systems and Engineering Leadership Program. There's a little white box right there on the website. You can go directly to it. It gives you a full explanation of how we develop our mentoring program at NASA.
Okay, so I hope y'all caught all that. It sounds like a great resource, especially if you're looking to perhaps start a mentoring program in your own organizations. So, um, Roger, you've done a great job of describing some of these approaches that you all use, both during your session and in this Q&A. Um, what can you tell us or share with us about some of the challenges or resistance that you all faced in the process of trying to trying to shift NASA's culture?
Yeah, I think the real benefit we had being a government agency, that we were directed by Congress, by the ASAP panel, to develop a knowledge management program. And so we didn't have to try to sell it to anybody. When the ASAP panel came down and said, uh, uh, NASA upper management, you need a chief knowledge officer, you need a knowledge management program, you need to share your lessons learned and the tacit knowledge within the agency. That was a dictate to us, and we had to do it. I
Mhm.
think with other organizations, that outside of the government, private companies and corporations, it's going to be a little bit difficult. And I actually have there's a chapter in my book where I talk about how to convince managers of why training and why knowledge management are critical for their organization. One of the, obviously the toughest thing to do is try to prove quanti- uh, quantitatively that yes, if you implement a knowledge management program, your company is going to save so much, $200,000 a year or something like that. You can't quantify it, but everybody knows that training is important and that sharing knowledge and learning from the past is important, and um, you have to be able to explain that and in a logical and intelligent way to upper management in a company that's basically very interested in making a profit. And
Mhm.
NASA, we're not interested in making a profit. We're interested in building, very difficult, very technical and hardware that works. So we don't have to worry about, what the bottom line is. And many organizations, they do have to worry about the bottom line, but you have to be able to prove it in a way that knowledge management is going to help the bottom line. You might not be able to quantify it in dollars and cents, but in common sense, you can.
Right. And for NASA, one of the keys too, I mean, in addition to the mandate that came down from Congress, et cetera, I think you can also draw a really strong correlation between the efforts behind knowledge management, the intent, purpose, et cetera, and NASA's vision and mission as an organization, right? And how knowledge management is helping you all achieve that vision for NASA as a whole.
Absolutely. And
Yeah.
then I make it, I got a feeling, Darcy, you may have read my book because I have a little portion in there exactly like that.
Not haven't read it fully yet, but have been skimming. Um, so Roger, there's a lot of people with questions about the the size and scope of KM inside of NASA. Um, so everything they want to know is there. So NASA has many sites. You know, there's the Kennedy Space Center, Goddard, JPL, et cetera, across the U.S. Um, do you all take a more federated approach? I know you have the chief knowledge officer and there's Apple, but aren't Goddard and some of the others, they also have kind of local knowledge management efforts. Is that correct?
That's exactly correct. Yeah. Every NASA center and every NASA mission directorate has a chief knowledge officer. And we
Mhm.
do have a federated arrangement. And doing it that way makes a lot more sense because I didn't want to be the chief knowledge officer at NASA headquarters telling somebody at JPL or telling somebody at the Marshall Space Flight Center how to do their job, because each of the 10 NASA centers have their own specific specialties, and they know their job better than I do. And I didn't want to seem like a bureaucrat from Washington telling them how to do their job. And it's actually worked out very well. I think all the chief knowledge officers throughout the agency, from all the centers and the mission directorates, meet once a month online, talk about the progress they've made, some of the opportunities that they have at their centers or the mission directorates, and some of the problems that they have. And we all get together as a team to try to, look at that and see if there's something interesting going on at JPL or something interesting going on at the Johnson Space Center, that we can share that with some of the other agencies or some of the other centers.
Great, great. All while striving towards this common objective for knowledge management. Yeah, so excellent. And so beyond the chief knowledge officers, are there other people who are dedicated KM staff, or that KM is like their full-time job across those centers, or with Apple?
I wouldn't say full-time job.
Mm-hmm.
Chief knowledge officers at each center and mission directorate, that is a full-time job.
Mm-hmm.
Uh, they can have some contract support staff to help them. I know at headquarters for Apple and for the training and for the knowledge management, we had a contractor staff of about, I think, a dozen folks that would help design courses and help write research case studies. And also at the centers for our lessons learned database, there's a volunteer group that will, if somebody wants to write a lessons learned to enter into the database, there's a volunteer group at each center that will review that and see if it's really is acceptable and applicable, or if it needs help, if somebody needs help writing one, they'll help do that. But just pretty much to make sure that the lessons learned databases are up to date and accurate.
Mm-hmm. Mm-hmm. Good. Okay. All right. That certainly makes sense given the approach and strategic direction that you described earlier. So another question that came in asks if, looking back over the time, certainly the tragedies were huge drivers, right, behind this. The emotional, as you put it, the emotion behind that has continued to kind of underlie, if you will, knowledge management across NASA. So this person wanted to know, if those hadn't happened, if those failures hadn't taken place, do you think getting where you are today with regard to knowledge management would have been more challenging to try to come together as an organization?
What an excellent question. Yeah, absolutely. I think as human beings, sometimes the only way we learn is through failure.
Mm-hmm.
And there was a quote that I read recently from one of the flight. Actually, it was from, I forget his name, but he was the head of Johnson Space Center during the Apollo program. And what he said was that if we hadn't had the Apollo 1 accident, we would have never gotten to the moon, because it was terrible tragedy as it was, and the loss of three really dedicated human beings. We discovered from that accident that the command module was not very well built, and we would not have gotten back to the moon unless we experienced that kind of tragedy that completely stopped the program for almost 2 years. They had to redesign the command module and redesign all kinds of different systems and components, and actually redesign a management system that would help us, get past the Apollo 1 tragedy and get
Mhm.
us to the moon.
Mhm. Okay. Okay. Um, so some of the one there's been a few people who have also asked, and this goes a little bit back, I think, to the kind of how CAIM is structured across NASA, and they're asking, are there do people have like performance goals or things like that that incent them in essence to make sure that they're contributing their knowledge, that they are um, looking for those lessons and applying those lessons learned. What kind of recognition or incentive programs are there in place, or maybe it's measures and metrics?
Yeah, actually at NASA, it is a requirement on every project that they, when the project is over, to develop some of the lessons that they've learned on that project. And it's part of the formal process that NASA has in managing project and program teams.
Hmm.
I think one of the things we also try to do is realize that our technical workforce, they're very busy. Sometimes they're working on something and they see that, yes, this is a problem. I fixed it, but I don't have time to write it down. I don't have time to actually be able to share it. And what we wanted to always let people know within the technical workforce at NASA, that if they do come across something like that, and they either don't have the time to write either a lessons learned or a case study about it, to contact us. And we have technical writers on staff that would be, you can just send us the information. We'll work with you to develop either a lessons learned or a pertinent case study that you can share that knowledge with the rest of the agency. And I think the other thing is, and this is a kind of a benefit of working with engineers. Engineers, just their general nature, they enjoy learning, and they have a kind of fascination with understanding like how bridges collapsed or how train wrecks happened and things like that. It's just part of their nature to want to troubleshoot and want to learn
Right.
from accidents and things in the past. So, uh, so if you're a chief knowledge officer and you're doing knowledge management at an organization that's almost strictly engineering, you get kind of a heads up or a step up that way, because you have an audience that's interested in learning and
Mhm.
not creating another problem or mistake.
Mhm. Mhm. I have a lot of engineers in my family, and I know their two favorite words are usually how or why.
Yeah,
How did this happen, or how does it work? Why does it work this way? How can
yeah,
we make it better?
yeah, exactly,
It's just how they're wired.
exactly.
Absolutely. Absolutely. Um, so, you've got, so there's Apple, you've got the podcast, you've got training and I can't even imagine other, how many, different repositories and things there might be across NASA to help people find the knowledge that they need, to answer questions, solve problems, et cetera, all those good things we want the knowledge to be able to do. How do you help people know where to go and to look for this knowledge, and or how do you connect all of that together so that they can find it?
That's another great question, and that's why we developed our website, because previously you had lessons learned databases that were beside some firewall at another center somewhere that nobody could have access to. What's the use of having a lessons learned database that nobody can have access to? So we had to kind of break down some of these barriers and talk common sense to some of the centers and some of the mission directorates to, let this information. That's the whole idea of knowledge management, is sharing knowledge. And if you had a problem um, on a program or project, let somebody else in the agency know about it, so we don't repeat it and we don't go through that same failure process. And I think the whole reason that we went to a one-stop website was to make it easier for anybody at NASA to either find out what courses are available, to find out where the lessons learned databases is, to make an easy search engine on there, to find out case studies if they have some time and they want to read about the Challenger or the Hubble or the Columbia or Apollo 1. that this information is easily accessed. And I think our web team did a brilliant job of organizing our website. And again, apple.nasa.gov. I welcome anybody to go there. It's not behind a firewall. And you know, and that's one of the things that we kind of insisted on is we were trying to share knowledge. And NASA is the type of organization that's it's for the benefit of all mankind. And for people out there anywhere in the world that we can help and that they can learn from some of the issues that we've been involved with, and use that as an opportunity of learning and avoiding failure. We want to make sure that that's open to almost everybody. So our website is wide open to anybody.
That's awesome. That's awesome. So one final question, Roger, and that is, what have you seen? What indicators have you seen in your time there that show that shift has happened in terms of that change to the culture? What are some of the things that you know, you've got the repositories and all the things we just talked about, but are there some other things that you've seen that show, yes, this impact is happening, we are making a change, we are headed in the right direction?
I could tell from a personal standpoint, I know when I first started at the agency, and actually, you know, before I was at NASA, I was working for other companies. And I mean, it was pretty much a military type of management atmosphere where your boss told you what to do and you did it, and you didn't question him or question him or her. And at NASA, when I first started there, it had some of that, you know, to it, because we were still going through the Columbia and the Challenger, you know, episodes. But you have to understand NASA's origins began actually during the Cold War. And so we had originally a military type of management system. And you have to, when the president tells you have to get from here to the moon in 10 years, and you don't even have a rocket designed. So you have to have somebody in a management system in there just pounding and pounding and pounding to get it done that way. But then societies grow and people grow and organizations grow. And after a while, that type of military type of do what you're told and don't talk back attitude doesn't really work. And NASA realized that obviously during Columbia and the Challenger program. So I can tell you from a personal standpoint, my experience at NASA, I've been there for 38 years, and I started at a center as an apprentice mechanic, and I was fortunate to have the opportunities to work myself up to chief knowledge officer at NASA headquarters. I had to deal with several chief engineers, and we had you have tough discussions about budget and priorities and things like that. I never once had a manager, particularly when I was at headquarters, tell me, no, you're going to do what I say, and it's my way or the highway. They were always willing to listen, and I think that the implementing the technical authority and the dissenting opinion and learning from the tragedy of Columbia and Challenger change that attitude and change that culture within NASA.
Mm-hmm. Mm-hmm. Roger, thank you so much for your time today. We really appreciate it. What a great story that you have to tell about your experiences at NASA and what you've seen and how knowledge management has evolved there. I want to thank you very much. We really, truly appreciate it. Everyone, I just want to remind you that you will receive a copy of the slides and the recording. You see, well, yes, links to those within the next 2 business days. So just watch for an email from apqc.org. And we are going to put up a little survey. So we invite your feedback to today's webinar. We would really appreciate that. And then I also invite you all to check out future events, including our upcoming conference in mid-April, as well as future webinars at apqc.org/events. It's all listed there. Thank you all for your time and attention today. I hope you have a wonderful rest of your day, and we look forward to seeing you at a future APQC event. Thank you all very much. Bye for now.
Thanks, Darcy.
Thank you, Roger. Have a great day.